In this video, we're going to look at two different methods for performing a paired t-test when we have dependent or correlated data. I'm using the blood pressure by time dataset available in the sample data directory. In this dataset, we have blood pressure measurements for 10 individuals measured twice during the day, once in the morning and once in the evening. We also have a difference score column, which uses the formula blood pressure PM minus blood pressure AM. Our first method to analyze these data uses analyze matched pairs. This platform expects two numeric columns representing the paired observations for each subject. I'll put in blood pressure AM and PM as my paired response. I'll hit OK, and we get the default matched pairs output. For summary statistics, we can look at the mean difference observed and the standard error of that mean difference, including confidence intervals, the sample size, and the correlation between blood pressure PM and AM for each individual. Our relevant test statistic is the t-ratio here, and we get a value that is statistically significant, indicating that, on average, we expect individuals to experience a difference between their AM and PM measurements. The mean by difference chart shows us each individual's average, so blood pressure PM plus blood pressure AM over 2, plotted against their difference from PM to AM, blood pressure PM minus blood pressure AM. The average here is the mean difference observed in the sample, 17.6, around which these difference scores for each individual, of course, cluster. Plotting against the mean lets us see whether individuals with a higher mean potentially show greater or lower amounts of difference. Here, we don't seem to see any systematic change in the difference score for those with higher or lower means. Also notice that 0 is not contained in the confidence band surrounding our observed mean difference. This is the same as saying that we've rejected the null with the t-test against the null hypothesis of a mean of 0. Since this hypothesis test is really a test of the difference scores themselves, another method performing the matched pairs t-test is using analyze distribution and providing the difference score column as our y. Our difference scores are shown here in the histogram, and our observed mean difference the same as it was before. To test whether this observed mean difference is different from 0, we can go to the red triangle next to diff and select test mean. Specifying the hypothesized mean is what we're specifying under the null hypothesis. 0 is fine for this case. If we know a true standard deviation, we can perform the z-test rather than a t-test, but in this case, we're estimating the standard deviation of the difference scores. To perform the non-parametric test, we can also select the Wilcoxon signed rank. When I hit OK, our hypothesis tests are printed out at the bottom. Our hypothesized value of 0 and our actual estimate, our degrees of freedom and standard deviation of the difference scores. Our t-test showed significant evidence, the same p-value and t-ratio as before, and the non-parametric signed rank test showing essentially the same level of evidence against the null hypothesis that the population mean difference is actually 0.